Hi there. So I promised that I would make some sort of video illustrating how the Serpent visualization tool works. So what I have here on the screen is a input file that I'm playing around with for Serpent, and it's a bunch of cards and stuff. And two things to notice, and what I want to do is I want to visualize this in 3 dimensions. So two things to notice. First, my entire universe is bounded by this cube. S9 is the name of it, and it has a characteristic dimension or characteristic radius. I guess you can call it an orthogonal radius. I'm hesitant to actually call it a radius. A radius of 80 units, 80 centimeters, I suppose. And I want it. So that's the first thing, because Serpent visualization tool needs to know this. And here at the end, I've got this comment Vizzle, V-I-Z-Z-L-E, as a comment. Kind of playing off, I was looking for a verb, visualization. Vizzle kind of made sense at the time. So those are the two important things to have in your Serpent file, is the card Vizzle, or the comment Vizzle, where you want the images or the plot commands to be generated at, and your bounding cube. The other thing is you should make sure that you don't have any other plot commands in your input file, or otherwise it won't work quite properly. So let's go into viz.py. So this is our Serpent visualization tool. So what you need to notice in here is that IM size, this sets the X by Y resolution of the image, so it's going to be 200 by 200 pixels. To process file name, that's your input file name, that's in the toexec.sssin, that's the extension I use. So that's the file name that we are working with over here. And these, both the toexec sssin and viz.py are in the same directory, so that's why I can do this. U0 radius, that's the 0th universe radius, is mentioned back here. Just ignore that this is 100, I'm just playing around with this. This is 80. The number of slices, so I'm going to have 100 slices. And don't worry about this, the scale factor. So you just have to make sure that you're in the same directory. So let's go ahead and execute all these lines, and I get CWD just to make sure that, yeah, we're in the same directory as here. Enter in these functions. Now you just click gen the images, and that'll go through and generate all the images. It takes a few minutes to execute. Okay, so that's done executing, and it's moved all our files to this images folder. Oh, that's the other thing I should have mentioned, is that make sure you have this images folder set up before you actually execute this. So this is in this folder is in the same directory as this viz.py file. So I have viz.py and an images folder, and this is where it stores all the images it creates. So it created 100 images as per the instructions for 100 slices, and each one of these images is 200 by 200 pixels. So on and so forth. And then we just gen the 3D file. It'll take a little bit to execute because there's 100 of them. Looking through some of the images created. Still executing. we go. Now if we look at our viz files, I created this viz output total.csv, comma separate value. I'm not going to open it because it's probably 100 megs. We just pop open ParaView. My recording software might freeze when I do the next step, so let's try it at any rate. So what we do is we open up our file creative viz output total. This SSS viz run output.txt, that's just the information created by the Serpent run. Pop this open, apply. Looks like my computer's still running, so it's going to take a few minutes to load because it's a couple 100 megs. I think it's usually like 131, 141 or something like that megabytes of data. If we take a look at HTOP, you can see that it's pretty running all out here. Yeah. When I'm not running OBS, usually one of the processors is in this fool. I've always wondered if there's a way to make oh, there we go. It's slow me a bit more multi-threading friendly. Okay, so there's our output.csv. Close that, and you can use table to points or table to structured grid. I'm just going to use table to points for now. Structured grid will get you a bit more performance, but it takes longer setup. Set our x column to x coordinate, y column to the y coordinate, z column to the z column, z column to the z coordinate. Apply, and then matnum for material number, and ta-da! There we go. We have a 3D visualization of our serpent geometry. So that's that for this video. If you have any questions, feel free to give me an email.